Appearing in the opening scene of Star Wars Episode V, The Empire Strikes Back, the planet Hoth is a frigid world of endless glaciers and frozen tundra. Though classified as an uninhabited planet, it is home to a reported 15 subspecies of the herbivorous tauntaun and a significant population of the large, possibly sapient predatory species called wampa. Though ice covers 2/3 of the planet's surface, a saltwater ocean encircles its equatorial region and shelters the majority of the planet's biodiversity. The planet is a frozen terrestrial 56% the size of Earth with a presumed surface gravity of 1 g. However, this would give it an estimated mass of nearly 0.32 Earth masses and an impossibly high mean density of 9.74 grams per cubic centimeter. If it instead possessed a more realistic, Earth-like density, Hoth would have a mass of only 18% that of Earth and a surface gravity of just 0.56 g, making it closer in size to the planet Mars. Hoth is reported to be the sixth planet of 6 in the system and orbits its solitary star with a period of 526 days, or 549 local days given the planet's 23-hour synodic rotation period. Practically nothing is known about the star that Hoth orbits except that it too is named Hoth. The Hoth star is reported to be blue-white in coloration, which would suggest that it's a spectral type A or perhaps a high-mass spectral type F main sequence star. For Hoth to have any chance of existing in the way it is depicted in the film, we must assume the latter case. Spectral type A stars are just too hot and luminous for Hoth to have surface temperatures low enough to even be habitable, much less support the existence of ice. The coolest star that could possibly be described as being blue-white would be a spectral type F2. This would give it a mass of approximately 1.5 solar masses and a luminosity of 5.5 times that of our Sun. Given Hoth's stated orbital period, it would orbit this star at an average distance of 1.47 astronomical units, and at that distance would possess an equilibrium temperature of approximately 271 Kelvin, or about -2 degrees Celsius. Though this sounds cold, it is actually close to 16 degrees warmer than Earth's equilibrium temperature, and thus would require Hoth to possess little to no greenhouse gases in its atmosphere in order to be the frigid world it is depicted as being. Of further consequence, Hoth is stated to be the outermost planet in the system, which would mean that the other 5 planets orbit at less than this calculated 1.47 AU. This might be plausible if these other planets were small terrestrial bodies, but unfortunately 2 of them are described as being gas giants, so it's likely that this system is too compact to be stable. Indeed, the small size of this planetary system is rather odd, as the planetary system of a spectral type F main sequence star should span over 60 times farther out than this. The Hoth system, terminating in an asteroid belt around 2 astronomical units, would seem to indicate that it interacted with another massive celestial body early on in its history, which scattered the planet-forming material beyond this point. Hoth is shown to be orbited by 3 major moons in what appears to be highly inclined orbits, but no information is available for any of them. So how does Hoth measure up as a science fiction planet? With Hoth's surface gravity never officially stated, we can't be certain of its actual mass and mean density values. But if we assume its surface gravity is close to 1 g, as has been reported by some sources, then its mean density is well beyond the realistic range for a planet, -1 point. No data exists for Hoth's orbital characteristics beyond the planet's orbital period, so 0 points. No data is given for Hoth's atmosphere or climate beyond it being breathable and cold, but if the assumptions I've made for the luminosity of its star, the planet's albedo, and the insulation of its atmosphere are close to accurate, then it is at least plausible that Hoth could have the climate it is shown to have, +1 point. With Hoth lying adjacent to an asteroid field, it is not at all unlikely that it would possess multiple moons. However, these moons would have to be very small in order to be stable, what astronomers sometimes call minor moons. A terrestrial planet cannot form multiple large spherical moons, or major moons, as once one is formed, its gravitational presence prevents the formation of subsequent major moons. While some might propose that a number of Hoth's moons didn't form around the planet but were instead dwarf planets captured from the nearby asteroid belt, this doesn't avoid the problem. Whether formed following a collision or captured in passing, the acquisition of additional spherical moons is an unstable event, as both scenarios start out with the second moon having a high eccentricity in its orbit of the planet, which will inevitably bring it into interaction with the existing moon. So Hoth having the 3 spherical moons it is shown to have in the film is not realistic. -1 point. Whereas, from an aesthetic perspective, I can understand the desire to place Hoth around a blue-white star. After all, a blue sun shining above an endless field of white snow would undoubtedly be a beautiful sight. But from an astrophysical perspective, a blue-white star is a bad choice. Main sequence stars of this coloration are extremely hot and luminous, requiring any potentially habitable planets to orbit very far out from them on very long orbital periods. These stars emit high levels of ultraviolet light, which is damaging to biological organisms, and they only live for a maximum of 2.5 billion years, making their planets unlikely to support anything but microscopic life. -1 point. With a total of -2 points, the planet Hoth from Star Wars receives a grade of F2. This is pretty bad, but not entirely unexpected. The planet's properties were defined by appearance alone, with any prospects of physical realism definitely left out in the cold. Thank you for joining me on this exploration of the planet Hoth from Star Wars. From here, I'll be charting a course toward another, hopefully warmer, alien world, and I hope to see you there. Until then, may the Force be with you.